Hey, what's up, fellow YouTubers? In this short video, I'm going to give you my thoughts and opinions of what I think about how to become a software developer, or as some of you may call it, a software engineer. So I'm going to explain to you the things that you need to know, the things that you should learn, what my thoughts are on what the best route to go, whether it's college or whether it's boot camp, and the resources. I'm also going to list all the resources down below. So even if you don't watch the whole video, you can look at the resources that I have outlined for you, and you can always go to those. And from this, hopefully now, if you're brand new to programming or you want to get into it, you'll have a better idea of what it takes, what my thoughts are, what the best route is. And so let's get started. Well, hello there, fellow YouTubers. So this morning I woke up thinking about something and just an idea for a video. And one of the things I want to discuss is that many of you want to get into programming, and I tend to see a lot of questions regarding why do we need algorithms, and what does it consist of? And then people want to know the fastest way to get in the industry and in the programming field. And so some things come to mind, and I think this is why a lot of times people don't really understand. People from the outside that haven't programmed before don't really understand what being a software developer consists of. And part of that is because we don't have the right mental model of what the skill requires. So there are several skills, and of course, universities prepare you a certain way. If you were to go to a college, well, I could say 20 years ago when I went, I don't know about now, but 20 years ago when I went to school, the focus would have been to get you introduced to programming. You might take maybe, and depending if you're going for a 4-year degree, let's just assume a 4-year degree. If you're going for a 4-year degree, you would probably need to take about three introductory classes to programming. And part of the reason for that is because back then there was still some Fortran out there. There was still some COBOL out there. A lot of the utility companies and things like that were still running COBOL systems, a lot of the banks. And I think, as a matter of fact, there's a lot of banks running even COBOL to this day. They are still running mainframes. They're trying to get out of it. They're trying to modernize to Java, but they're still using some COBOL, or even sometimes they're converting their code to COBOL. So there's a few things when it comes to programming. One of them is, well, the language. And the language is really just a syntax. And think of the language in terms of a tool. So just think of, let's not even think about programming language, but let's think about just a language in general. So when you talk about a language, let's say, for instance, English, even, a first grader can speak English, but what's the difference between their use and maybe someone at a college level and how they can use the language to convey different information? Or maybe even a professional writer, the way they may be able to write a novel with their creative writing. So you think of the tool as, it's like, okay, yeah, you know the language, but what can you do with it? And so learning to program consists of, one is the use of the language, which can be very simple or very complex. Most earlier languages were very simple to use. They only had a few constructs that you had to really be concerned about. And now when it came to newer languages, it got a little bit more challenging, right? For example, C in and of itself has some complexities. I could say, like managing pointers and things like that, and pointers to pointers and all that. And so they can be challenging, but C is still pretty simple language. Now compare C to C++, well, it gets a little more challenging because C++, now you get into the world of object-oriented programming, where C is mainly procedural programming, and then C++ is object-oriented. So when you start getting into object-oriented, then there's other concepts that you have to learn. For instance, you start learning about object-oriented languages, then you have to get into the whole idea of properly using and designing objects to fit your programming needs. So there's a whole host of topics that come to mind in that regards. For instance, inheritance, abstraction, dependency injection. Those are a few things. Then there's design patterns, which you're going to run into problems where you need to do certain things, and they've already, it's not a new problem, it's an existing problem. And if you're aware of it and you have the knowledge of the design patterns, then you can use an existing solution to a recurring problem. And that's one thing. But then you also, when you start doing business domain programming, you get into things like domain-driven design, which kind of take, I think domain-driven design takes a little bit from the patterns of enterprise application architecture from Martin Fowler. So Martin Fowler wrote the book Patterns of Enterprise Architecture, and well, that book lays out a lot of the patterns at the time that he wrote it that were common. And believe it or not, some of those patterns are still exist, and they're still common. And sometimes we go in circles because we might use one pattern one way, and then down the road we decide that maybe one of the other patterns that it talks about fits a little bit better. And then some of them are just modifications or mutations of those patterns, right? So they're still, even though that book has been around for a while, it still stands the test of time. And then there is, like I said, domain-driven design, which gets into the whole how to write applications in a way that you make them more maintainable. And by using these separating into these different types of modules, I guess I could say modules because I can't think of something better, but it gives the idea of the data transfer objects, aggregate objects, entity objects, value objects, and anti-corruption layers, separating one piece of your architecture from another piece of the architecture, and how to protect them between boundaries so that they're not all one big couple chunk of stuff. And so it gets into a lot of that. So then that's another thing to learn. And that's like a course in itself, if you think about it. So you got design patterns, which is a course in itself. You have domain-driven design, which is a course in itself. And we haven't even gotten into some of the computer sciencey stuff. So like data structures and algorithms, right? So I think data structures are important to know from the perspective of you as a software developer should know how to create your own data structures. You should, like I said, you should. Will you need to during your tenure as a software? Probably not, because all frameworks in all languages have libraries that already implement those. But it's good to know them so that you understand them and you understand their use cases when they're best suited for the things that you need them for, and for their advantages, disadvantages, and just understanding them. It just always helps. Anything is helpful, right? Because if you know how something works, then you know how to use it better. That's one thing. So that's data structures. And algorithms is another thing that you have to take into consideration, because some of the software that you may work on may be a 24 by 7 operation, and needs to be up all the time. And not only that, but if it's a successful business, it'll scale, it'll grow. And if it grows, then that means that it has to be robust, and it has to be performant. And you can go, let's say, for example, from 1,000 users to 10,000 users to 100,000 users, and it has to all scale well. And part of that scaling has to do with the performance. And how do you know the performance? With the algorithms, but sometimes not even just the algorithms, it's the nuances of like languages and maybe even databases and how databases operate on things and how efficient you are at pulling something. Just to like kind of give you one example, when .NET first came out, they were really big on pushing the idea of these things called the ADO.NET, which was basically data sets and data tables in memory. Basically, they provided a lot of the mapping for you to pull data from a table in the database and fill your data. But one thing that they didn't a lot of times provide was a good way of using it. For example, you know, you shouldn't probably pull the entire database into memory. That's probably a bad idea. You know how to pull exactly what you need. So other things came along the way, like Hibernate, where these object relational mappers provided a better way for you to query for the data that you need. And of course, from that, they learned and they had things like Entity Framework for Microsoft. And then there's a whole host of things on the other side of Java, like Hibernate. And you know, a lot of those things. But now where it seems like a lot of times we're going back now because we want to be more specific. It's just, there's always going to be a disconnect between the backend database and the code, you know, because in database, you're working with relational data that is all normalized into tables. And then on the code side, you're working with objects. So to make that connection, you need something in the middle to kind of bring those two technologies together. So now in that kind of programming, you got to think differently. It's not purely just objects. It's more like how do you separate the logic, because there's disconnected pieces. On one side, you might process something. On another side, there may be something else that processes it in the background that queues it up as a job and comes back and then notifies the individual. So it's a lot of disconnected pieces that form one big workflow. So when you start thinking about how much you have to learn, well, there's this significant amount. And so sometimes I used to be, at one point I was kind of skeptical about the boot camps. And then at some point I was like, oh yeah, this is a good thing. You know, these boot camps are a good thing. But then having experience and knowing some people that went through boot camps now, I think that boot camps are really good if you already have some understanding of, like, let's say, for example, for me, let's say I wanted to become a Ruby developer and I get in a full stack Ruby developer boot camp. So for somebody like me with 20-something years of experience programming, then it would be good because I would learn all the nuances of Ruby, but I already have a lot of understanding of how applications work and what it takes. So for somebody like me, then I may also be in there and be a fast tracker, be able to keep up with what they're saying. But from my experience, if you're brand new to programming, boot camps are just not a good way to go. I've changed my opinion on that. And I just don't think that you can cram that much knowledge that quick, even if you're really, really smart. And part of the reason is because the way your brain processes that information, you know, your brain, it takes time for it to realize stuff. It's amazing. I don't know. I'm not a neuroscientist, but I do know that sometimes it's like I might have taken an algorithms class, you know, one semester, and certain things don't click like till 2 or 3 semesters down the road. So when you're trying to cram all that information from a boot camp, and a lot of times boot camps don't even go over algorithms. They don't teach you how to think in terms of programming. All you're doing is taking data, pushing it to a database, pulling it out, displaying it. And even though you're taught good practices, you may not be good, because like to become good at programming, it's like anything else. You have to practice and you have to study and you have to reflect. So, you know, going back to the original topic of what is programming? Well, one part is learning the language. The other part is becoming a skilled user. And some people like to compare it to a craftsman, some to an artist. Whatever the case may be, it is a skill, and you get better at it only by practice, only by practice. And so So that's the idea there. And a lot of times I know some of you want to just get in the field and start doing things. And, somebody might give you an opportunity if you go through a boot camp, spend 6 months and then go through a boot camp and then get a job and start working. And they may give you an opportunity and then you learn more in the job on a trial basis or something like that. But, software development, you're going to have to put some focus effort. And if you don't go to a traditional college, which is my number one recommendation, if you want to be a software developer, a programmer, my number one, I think college is still the best route. Okay. Yeah, you can try to do it on your own, but as we know, even students are lazy when it comes time, or I won't say lazy, but they're procrastinators, right? And so, but they're forced to get that grade. And if they're forced to get that grade, they're going to work to get that grade. And one of the hardest things to have is self-discipline. So unless you have a lot of self-discipline, and when you're young, you typically don't, then you're not going to be able to teach yourself how to program. Not only that, but you're still, even if you went the route of self-taught, you should still plan and budget for having some kind of tutor or mentor that comes and explain. That does work for you because it's not the way to go. But as somebody that teaches you along the way, that says, hey, you're stuck here because of this. And I mean, you can search the answers on your own, but sometimes it's better to have that one-on-one, that conversation, that dialogue. So that way, when you have a question, you get that instant feedback instead of, hey, you posted on Stack Overflow and here it is 30 minutes later, you might get a response, you might not. Or you're looking for the answer online, but they only gloss over the answer and they don't really provide a good solution. And then you have more questions on it, but you don't have anyone to ask. So that's what it is. It takes a lot. You got to learn the tooling. You got to learn a lot of techniques. You got to learn approaches. You got to learn a lot of different concepts. You got to learn a lot of things. And I say that if you wanted to let's say that even a college degree, even if a college degree offered just a straight route, no basic courses, no common courses, no English, no history, no none of that stuff, right? Even if you had that, in my opinion, you still need a solid 2 years of learning the technology. All right. So you would need a solid 2 years because at a minimum, you need to know how to program, right? So basic introduction to programming, advanced programming, data structures, algorithms, database systems. And I would even dare say to learn about other database systems because there's, of course, document database systems like Mongo, NoSQL database systems. And so we're talking 6 classes already. And then more practice classes like a software engineering class, maybe a project management class, maybe use of tools along the way like Git and stuff like that, GitHub. So I would say that, and then of course you need to have some understanding of maybe networks and how they operate, because it's going to come into play. At some point, networks comes into play, even with your own applications, even if you're running them locally. So I can think of at least 10 classes that you would have to take in order to become proficient. And like I said, that span of time from when you learn something to when you grasp it, and repetition, because programming is a lot of repetition. I don't know how to play any instruments, but I know that I've done other things in my life that require skill and require practice. And so if something requires practice, you have to repeat it, try it, learn along the way. And your brain is kind of magical that it knows something, it recognizes, and they're able to grasp it. So you do need that in between. So would I recommend boot camps? Unless you're already a skilled software developer and you just want to get on a particular track, I wouldn't. I think you're risking a lot of money and you're going to end up with not very good results. So it's better to go the long route, in my opinion. College degree is definitely the best way to go. And really, that's all I got to say. If you like this video, give it a thumbs up. And if you don't like it, give it 2 thumbs down. And 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 certainly if you don't like it, let me know why and give your opinions on things, and leave a comment below, and I'd be glad to answer it. If you have any questions, drop a comment. Thanks for watching.